So, this is day 4, unit 3 or chapter 4, and this is kind of a review, but it'll be a lesson on box method and grouping. And really, the main thing is that when we have a trinomial and it has a leading coefficient, our job's a little bit more difficult. So, I'll show two methods, grouping and box method, but they kind of start out the same way. So, either way, when we start out, we want um, we want to multiply a and c, and recall that our a, b, and c are the coefficients of x squared, x, and then also your constant number that doesn't have an x. So we multiply a and c, and this is going to give us. So I'll do this in the middle here. It multiplies to be a negative 36, and so we're looking for two numbers that multiply to be a negative 36 and then add to be a positive 9, and that's the middle term. Okay, so the only difference between this and when we were just doing double bubble, or we were just factoring when it didn't have a leading coefficient, we didn't have to worry about multiplying these two, because 1 out front times this would be the same thing. So, and we were just able to think of two numbers to multiply to be third number, add to be the middle. But now with the leading coefficient, this is the first step we have to do. So then I could write these out, and if you're not sure what divides 36, you can always just go down the list. And say, okay, 36 divided by 2, 18. So we know, first of all, 36 and 1, 18 and 2. If you had 36, then you could try 3, go up the list, so divide by 3. Then you'd have 12 divided by 3. The next one, divide by 4. It also is divisible by 4, 9 and 4. But we know that these have to be, one has to be negative of each pair because we multiply to be a negative. So, if it adds to be a positive number, that means that the smaller number has to be negative, because really when you add these two, it's kind of like subtraction, and you get 35, but it's a positive 35. If the 36 were negative and the 1 were positive, it'd be a negative 35, and that's farther away from what we want. So we know that the smaller number in each of these is going to be negative. And then just check it out. So this one adds up to be 16. Nope. This one adds up to be 9. Yep. So I don't have to do any more. I found it. Now, this is where the two methods split. First of all, these two numbers we just found out, that's what this 9x turns into. So essentially, we have the same polynomial, or the same trinomial in this case, 2x squared, and instead of 9x, we have plus 12x minus 3x, and then minus 18. And from here, we can use grouping method or box method. I'll do box method over here, but we're using the same terms we have. Just list them out in the box. Just kind of left to right, top to bottom. So 2x squared, 12x, negative 3x, and negative 18. And just a word of a note, I guess. Your first and last terms could have gone in the box right away, in the diagonal left top and bottom right. We just did this first work to figure out the two numbers to multiply to be negative 36 and had to be 9. Those go in other spots. The next step is to take out a greatest common factor from each column and each row. So 12x and negative 18, they don't have an x in common. They're both divisible by 2, 3, not 4, 5, 6, and that's the largest one they get. So I would take out a 6 from both of those. And another piece of information to review, it does matter the negatives a little bit. We only care if the term that has more x's is negative. If that's negative, then I'm taking out a negative. Whatever I take out, it's got to be negative. But since 18, it's a bigger number, but it doesn't have an x, so I don't care that it's negative. On the other hand, negative 3x and negative 18, I don't care that the 18 is negative, but because this one has more x's and it's negative, that tells me I'm taking out a negative. And the largest number they have in common, certainly no x's, is a 3. So negative 3 I take out from there. We can do these in any order. So maybe this row here, 2x squared and 12x. there's a 2 in common, and an x, 1x. That's how much they have in common. And between these two, they don't have any common factors for numbers. They're both only divisible by 1. And they do have at least one x in common, so this is x. And that's what we end up with. We end up with x plus 6 and 2x minus 3. Okay, if we were to, so that's one method, and we'll still find the zeros here in a second. Set it equal to 0, and we have x plus 6 equals 0, and 2x minus 3 equals 0. And subtract 6 to each side, and you get -6. So that's one. This other one, we actually have to do a little bit of work for. We have to add. We have to solve it. Add 3, and we get 2x equals 3. And you divide by 2. So x is 3/2. Okay. So the other method is called grouping. Because what we do is we put these two things into groups. I say I'm going to put the first two and the last two into groups. And then factor them out. And so and factor out GCF, kind of just like I did in box method, and you'll see something interesting happen. 2x and 12x, they have a 2x in common. And then what's left over in the parentheses, just these first parentheses that I took the 2x from, is just an x and a 6. Look familiar? The other one, I'm taking out a -3 because they both have a 3 in common, and this first term is negative because it has more x's, so that's why I'm taking on negative. So -3, and then write what's left over. X plus 6. It's plus because I had -18, but I divided out a -3. So -18 divided by -3 makes a +6 left over. And if you notice, we have this big long expression, right? And so if I'm just looking at this chunk right here and this chunk right here, it's like I have a subtraction. It's like this big term minus this big term. But each of these terms then have something in common. Namely, they both have an x plus 6 in common. So let's give it some writing here. Since they both have this in common, I can take that out as a greatest common factor. Because this whole term has an x plus 6, this whole term has an x plus 6. So if I take that out, x plus 6, I take it out front, and it's now divided out of both of these terms. So all that's left over is 2x minus 3. All right, so you'll see that we have the exact same thing that we did with box method, and we would set it equal to 0 in 2 cases, and then you'll get the same thing as we did there. So that's factor by grouping, and then the other one was box method. Either one is good. Factor by grouping is good because it kind of follows the same idea of reverse distribution or of factoring. Like when we factor by grouping, and we have now two kind of chunks. We have 2x times this thing, but then they're separated by a plus or minus sign, and then 3 times this thing. So we have 2 chunks, but each of those chunks happen to have something in common. And so then we're just factoring again. But box method's kind of slick because it's just a procedural thing, and visually some people like it. Oh boy. Oh, I got computer problems. Okay. So same deal. I'll do factor by grouping and box method. Here are my 2 numbers, a and c. I'm going to multiply those. Multiplies to be a -16 and adds to be a -15. So I'll start at the top. I know that 16 and 1 multiply to be 16, 8 and 2, 3 doesn't work, 4 and 4, and then that's it. I know that one of these have to be negative because it multiplies to be a negative. And when I add them, I get a negative, that's -15, so then my larger number has to be negative. So I can add these up. This one gives me 0 if I add them. This one gives me a -6. This one gives me a -15. That's the one we want. So grouping would look like this. We just take these two numbers, and that's what 15 splits into, 15x. So this would be 4x squared minus 16x plus 1x, and then our last term, minus 4. Okay, and then we're grouping them, affected by grouping. And notice I left the plus sign out of the parentheses here, and this is the way it should look, but just to be consistent, you'll notice up here, I put the negative inside the parentheses, and it was really, I don't enjoy doing that, but I wanted to show it so that we know that both of these terms are negative. Because this first term, if it's negative, I have to take out a -3, whereas if I drew the parenthesis right here, we might look at it and say, oh, it's a +3. I'll take out a positive because I don't care about that one. But it's actually, it's a -3. So, and that means we're dividing out a -3 from the -18. If I just take a 3 out, this is going to be a negative, and these aren't going to match. So it's not a huge point, but it's just something that maybe could be a cause for confusion. All right, so we're just taking out a greatest common factor from both the front and the back, first term and the last term, first two and the last two. So this one, they both have an x in common, they both have a 4 in common. So 4x. And then what's left over? It's like you're dividing it out, so divide 4x squared divided by 4x, the 4's are gone, one of the x's is gone, so just 1x left over. In this case, both x's, if I divided a 4x out of the -16x, you'd get a 4, and then the x's would be gone. These two, they don't have anything in common, so the only thing I could take out is a 1. And then we'll see that what's left over is 1x. Dividing both by 1 doesn't change it, so x minus 4. And then we can see these are the same, so we're going to factor out an x minus 4 from both of these chunks. So this is x minus 4 out front, and what's left over is 4x plus 1. Your last step, set it equals 0, and do your two cases. X minus 4 equals 0. We'd add 4 to both sides, and you get x is 4. In this one, 4x plus 1 equals 0. We actually have a two-step equation, so -1, -1. 4x equals -1, and divide by 4. So x is -1/4. All right. That was grouping. Here's box method, and this is the exact same. We did all the legwork already. We already have that. So we can fill in our boxes. This is 4x squared. The bottom one was -4. We knew that right away. The other two are -16x and 1x. Just make sure we remember when we get these two numbers that they get x's when they're put into the boxes. Okay. GCFs of each row and column. So here's the first row. They have a 4x in common. This one, they just have a 1. There's nothing else I can take out. In this one, there's no numbers other than 1, but then they also have at least one x in common, so x. And then this guy, the term that has more x's is negative, so I'm taking out a negative for sure. And then the number they have in common is a 4. And so we just put these around parentheses, and it's factored. And this is 4x plus 1. And you see we get the same thing here, so I won't solve it twice. All right, so there was two methods to factor a trinomial and find the zeros when it has a leading coefficient, when it has a number out front there. All right, hope this works out for you, and good luck.